we're going to share the entire desktop. Okay. All right. So no major announcements. We finished section 2.1 last class. So we're going to take today and tomorrow to kind of, we can either, today we're going to be working on the homework for section 2.1. More than likely tomorrow, we'll do some review on factoring, because I know that factoring is one of those topics that typically gives students a hard time. So I usually like to, especially since we have extra time, it'll be good to kind of review some of that. Okay, but for today, we're going to work on the homework for section 2.1. So let's hop over to the homework, which is here. Okay. This asks us to identify the graph of the quadratic function. So we see that it's a parabola and it should be opening downward, right? So let's see. And we didn't move it left to right, nor did we move it up and down. The only one that's opening downward without moving is C. This one opens downward, but it was also moved up. So that's not correct. This is the only one that fits the description. Okay. So this one, we're choosing a graph. It's a parabola where we go left one and it opens downward. This one goes left one and opens downward. This one went to the right, so that's not it. And these don't open downward, so it should be A. Okay. And I'll be monitoring the chat. Feel free to type in the chat or unmute yourself if anything is not clear, and we can stop at any moment and look at whatever we need to look at. Choose the graph that represents the function. So this is a parabola where we go right 5 and down by 9. And it still opens up, right 5 and down. This one, right? This is the only one that went right and then down. Nothing else behaved that way. Okay. So this is a parabola where we go left 3, it opens down, and we go down by 1. I think this is the only one that does that. Left 3, down 1, opens down. So I'm going to choose this one. Okay. Find the quadratic function of this form that passes through this point. So when x is 3, y is 36. So if x is 3, 3 squared is 9. 36 divided by 9 is 4. So without writing that one, I'm just going to say this is going to be 4x squared. Okay. Find a quadratic function that has this vertex whose graph passes through this point. Let me see, that's the x and the y. I'm going to write this one out. Okay. So this is section 2.1. This is question number 6. This comes from section 2.1, number 13. Okay. It says that the vertex is the origin, and it passes through the point 3, 27. Okay. And write it in standard form. We're going to say write in standard form. Okay. So let's hop over to the tablet and let's show the tablet. Should be showing. I need you to get out of the way. That looks good. Okay. All right. So if we're going to write a quadratic in standard form, it's good to start with the standard form of a quadratic. That's going to be f of x equals a times x minus h squared plus k. Okay. So if we have the vertex, this is going to be our h, this is going to be our k. I'm passing through this point, so this is going to be our x, this is going to be our y. All right, so let's plug in what we have. So our y is 27. Let's bring down our equal sign. So let's bring down our equal sign. Y is 27. We don't know what a is, so we're just going to bring that down. X in this case is 3. Our h is 0, and our k is 0. All right. So that gives us 27 equals 9 times a. So then divide both sides by 9, our a equals 3. Okay. So then our function is going to be 3 times x. I think it's just 3x squared. Okay. Okay. So let's hop over to Pearson. Wait, before we hop to Pearson, let me see. When x is 0, y is 0. When x is 3, y is 27. That checks out. So let's hop to Pearson. Fractions, or 3x squared. We got 3x squared. Okay. Given vertex passing through that point. Okay, this is question number 7. So let's take some notes. This comes from section 2.1, number 17. The vertex is going to be 3, 2. Passing through 2, 4. Okay. Let me make this presentation a little bit better. Okay. Okay, that looks good. Okay. So let's hop over to the tablet and let's show the tablet. Okay. And let me check one other thing. Standard form. Okay. So it wants to answer in standard form. Again, standard form is f of x equals a times x minus h squared plus k. Okay. Let's see, the vertex, that's our h and our k, passing through this point, so this is our x and our y. So then let's plug these components in. So our y is 4, our a is here, our x is 2, our h is 3 squared, our k is 2. Let's see who we got. Okay. All right, if we keep going, make sure I'm showing the right thing there. Okay, that looks good. Okay, so then we'll have 4, a 2 minus 3 is what? Negative 1 squared is 1, so that's a plus 2. Subtract 2 on both sides. We get what? A equals 2. Okay. So then our function, our f of x, ends up being 2 times x minus, what's our h, is 3 squared plus 2. Okay. We can check this. We can, given the x, make sure that it has the proper corresponding y. Okay. So then when x is 3, 3 minus 3 is 0. The answer is 2. That's correct. When x is 2, negative 1 squared is 1. 2 plus 2 is 4, which is correct. Okay. So I'm going to stand by this. We're going to hop over to Pearson and submit this result. Oops, Pearson is this way. So then the function ends up being 2 times x minus 3 squared plus 2. Let me think about it. X minus 3, 2, let's go back. Where could we, oh, I put a cube instead of square, right? So that's just a typo. That's a 2. Awesome sauce. Okay. Determine the quadratic function of this form whose graph is given to the right. So we have a graph on the right, and it shows the vertex, and it shows an additional point. So this is kind of a repeat, just a different presentation of the same question. So this is question number 8. Número 8. Habla español. Y habla español un poquito, pero es difícil para mí comprender la persona porque habla muy rápido. So yo digo más despacio, por favor. More slowly, please. That's all. That's actually all the Spanish that I know as well. But I can say it. Oh no, did we lose our work? Oh, I hope not. Doesn't look like we did. I'm trying to click here. Chat. Max and min value. That is coming up. Yes. For this class, Alex is 10% of our grade. All right. I don't know the knowledge check. It's just we need to be doing about at least 25 topics per week. And as long as we're completing about 25 topics per week and we finish at a level of prep for college algebra or higher, then we're okay. I think we will get across to one that has a max and min value. I guess we can go straight there. If you can find it in this set and just let me know which one it is, we'll go to that.
It's number 14.
14?
Yeah.
Okay. We'll do that one next.
Thank you.
We can do it now because since this is kind of a repeat. Let's go to number 14 and we'll come back if we need to. So it says determine whether the given function has a max or min value and then find the value and find the range. Okay. So let me see. The leading coefficient is positive, so that means the parabola opens upward. If the parabola opens upward, that means we're going to have a minimum value. So the answer here would be A. Okay. The minimum value is going to occur at the vertex, so we need to find the vertex, right? This is number 14. So then number 14, again, the original, we have f of x. Let me take some better notes than this. So this is number 14. This comes from section 2.1, question number 43. The original function, our f of x is, we got this 3x squared minus 18x plus 31. We're talking about max or min. Okay, this one's going to have a max value. And then that's part A. And then part B, we're asked to find the range. Okay. Let me see who's coming in. Users. Strangers. Come on. I really like you guys, this class, because when you guys come in, then I just be aware of the time. And I was like, oh, I'm almost done for the day. Then I get excited and it revs me up. So, okay, we're going to go ahead and let him enter the class. That looks good. And it looked like he disappeared. There he is. That's correct. Okay, he's on his way in. All right, so let's hop over to the tablet and finish out this question. And we need to show it like this. Okay. So again, because the leading, this is a quadratic, so it is a parabola. Because the leading coefficient is positive, that means the parabola opens upward. Sorry, we're going to have a minimum value, right? Yeah, because the parabola opens up, that means we're going to have a minimum value. There's no max, but there's going to be a minimum value, okay? I think the question asked us to find, before the range, find the minimum value, right? So the minimum value is going to occur at the vertex, right? So then let's just find the coordinates of the vertex. The x coordinate of the vertex, which is going to be our h, that's going to occur at negative b over 2a, right? So for this example, that's going to be negative, our b in this case is negative 18, so it's a double negative, over 2 times our a is 3, right? So that's 18 divided by 6. So the minimum value occurs when x is 3, and the minimum value itself is actually going to be, now we got to find the y value of the vertex, the y coordinate of the vertex, which is our k, and basically we do f of h. So whatever answer we find, we just pass it to the function. Okay, so that's going to be f of 3. So that's going to be 3 times 3 squared minus 18 times 3 plus 31. Again, you can use calculators. I'm just practicing my handwritten work or whatever. That's going to be 27. 30 plus 24 is 54, so minus 54 plus 31. If that's 30, that's what? 24, 27. That's a negative 27. That's a 3 and a 1 is what? 4. I think ultimately the answer is 4. So that should be 58. That looks good, right? 4. So when x is 3, y should be 4. So the minimum value of 4 occurs when, let me see. So to answer the question, the minimum value of 4 occurs when x is equal to 3, right? So that's answering the question directly. Awesome sauce. It actually got that shape. Okay. And then the range, so if the minimum is 4, the range is going to be from 4 to infinity. And it actually reaches the 4. Okay. All right. Let's see. Okay, I feel good with this. So I'm going to hop over to Pearson. Let me see. Is this should be a minimum value, very bottom. Yeah, feel okay with this. We found the vertex. Okay, let's plug it into Pearson. So let's hop over to Pearson. Right there. Pearson is going to be here. The minimum value is going to be 4. Should just be 4. Awesome sauce. The range, it goes from 4 to infinity. Let's check the chat. Can I just do this? Oh, got a little overzealous. Okay. Let's go like this, and then check the chat. Number 11? Okay, we'll do number 11 next. All right. What's the range? So we said from 4 to infinity. So we're going to do a square bracket from 4 to infinity, parentheses. Awesome sauce. Okay. Let's hop over to question number 11. Oh, man. What do I need to do tomorrow? Oh, my goodness. It just doesn't stop. Ooh. Time is 5:43. Okay. So we're asked to graph this function by writing it in standard form and then using the transformations on this and then find the vertex. Okay. Should I screenshot this? Let me see. So if I go like this, that does, ooh, that actually works for me. I can see that clear. Okay, let me get a copy of this. Yeah, that's good enough. Go like this. I want it from here to here. It's pretty good. From there up until here. And what I want to do is if I hit share, there you go. Come on. Thank you. That looks good. Okay, let's hop over here. Do I need to? Yeah, I need to reboot you now. I'm gonna have to. That's okay. We're done with this. Let's hop over to the tablet in just a moment. That's this class. I'm gonna go ahead and load this screenshot I just took. So I'm gonna add photo. It's this one. Add. Yeah, this is right. Do we have space? Yeah. Okay, that looks good. Then let's hop over here and let's make sure that's shown. Okay. All right. So this is the one that we just got, right? We're asked to graph this function by writing it in standard form and then using transformations find all of these components. Okay, so first task is we want to write this in standard form. There's a couple of techniques. You can either use the Vertex Formula and just fill in the standard form formula. I'm going to do Completeness Square. This is a great opportunity to do a demo on Completeness Square. Okay, so we're going to have y equals, come on, negative 2x squared plus 16x minus 23, okay? So now we want to do completeness square. The first goal of completeness square is that that leading coefficient needs to be a 1. So what I'm going to do, I'm going to factor out negative 2 from the first two terms. And actually, I need this to kind of go to the far left over here. I'm going to factor out negative 2 from the first two terms, right? So if we do that, the following happens. So we're going to factor out the negative 2. We're going to need about this much space. This negative 23 is going to kind of be over here by itself. Now, if we factor out the negative 2 from the first two terms, we're going to be left with x squared minus, what is that, 8x? And I wanted to leave about that much space. Okay, so if we multiply back, I think we're okay. So now the completeness square step comes in. We want to say we're going to add 0 by adding something and taking it away, right? So we're not going to, if we add 0, we don't change the answer. We just change the form into something that we can use, right? So we're going to add 0 by doing the following thing. We're going to say plus b over 2 squared and minus b over 2 squared, okay? The b in this case is going to be the negative 8. So we're going to say plus negative 8 over 2 squared and minus negative 8 over 2 squared. Again, we're just adding 0. So what this does is change, it doesn't change the answer, it just changes the form of the question so that we can proceed, right? So if we say negative 8 divided by 2, that's going to be negative 4 squared is a positive 16. Sounded like a rap video. Negative 8 over 2 is squared, b over 2 squared, it's not fitting here. But I can do it. Sometimes I'm able to get it, sometimes it fits. I gotta hit the source. I need my other app mic because I'm set the playlist. I can't get it. I gotta hit the source. I need my other app mic because I'm set the playlist. Using this class right college I'm educated to got my back. So we go keep jumping. I can do it with the music. I can't get it right now. Totally sleepy. But yeah, sometimes I can get that stuff. Sometimes, not right now. But that's. I might put the song on and see if I can do it later. But it might be some copyright infringement, so I'm not gonna do it right now. But it's just fun. It's just fun stuff. Okay. So negative 8 divided by 2 is negative 4 squared is 16. So what we're really doing, we're saying plus 16 and minus 16. And everything else stays the same. We're just bringing everything else down. So all of this stuff here. Copy. Everything in black is just staying the same. All right? Boom. Just like that. Okay? All right. So now we want to factor out that negative 16. We're going to have to distribute the negative 2, right? So I'm going to do the following. We have y equals, we got negative 2 times x squared minus 8x. Again, this first 16 just persists. Now, what I'm really doing, I'm distributing this negative 2. I'm saying that the first part times negative 2, and I'm saying this times negative 2. That's what I'm really doing, right? So then we're going to have negative 2 times this negative 16. Hopefully this makes sense. Okay, and then the negative 23 persists, okay? So then the whole point of completing the square is now we can factor those first three terms. Those first three terms now are going to factor into plus, so they're the same, so minus 4, so x minus 4 squared. And just to kind of show you where it's coming from, style, this is coming from this guy. The blue part, right? That's the motivation for that. Negative 2 times negative 16 is 32. That's going to be a 7 plus 2 is a positive 9. All right, so we're going to say plus 9. Okay, so that was a demo on completing the square. This is why I was like, we need to take some time to factor, because I know this gives students a hard time. So with our extra time, like, I mean, our rhythm seems to be, we need approximately, give or take some time, but we need about 2 days for the lecture, right? We don't need all 4 days, right? So 2 days we might spend on the lecture. 1 day we might spend on the homework. And then the rest we're gonna start looking at just practicing, taking some time to practice factoring, right? Because we're not gonna get any other chance to practice that. And I know that this always gives students a hard time. Not all students, but most students don't know this like the back of their hand, right? So that's why we need to take some time and look at factoring. So more than likely, that's what we'll be doing on Friday. Yeah. Okay, let's answer the questions. So we're going to graph. We wrote it in standard form. I'm going to stand by this result. Okay, and then the vertex. Now, let's do a demo on the using the vertex formula. I know we can pull the vertex from this, right? But let's just do a demo using the vertex formula. So the x-coordinate of the vertex, which is our h, is going to be negative b over 2a. Okay. So in our example, that's going to be negative. Now from the original, that's going to be negative 16 over 2 times negative 2. 16 divided by 4 is 4. So the x-coordinate of the vertex is 4, and it matches what we have up above. Then the y-coordinate of our vertex, which is our k, is going to be f of h. So whatever answer we found, we just plug it into the function and solve. Okay, so in this case, that's going to be f of 4. So then from the original, that's going to be negative 2 times 4 squared plus 16 times 4 minus 23. 16 times 2 that's going to be a negative 32. Let me write this out. It's going to be a negative 32. What's that going to be? 64? 40 plus 24? 64. So plus 64 minus 23. Okay. That's a 30, 34, 32, 7, and 2 is 9. And that matches what we have as well. Okay, so the vertex ends up being 4, 9. So we found the vertex 2 different ways. You can pull it from the standard form or use the vertex formula, right? This is the vertex. I need to go see if I can find that quick. I should probably go to hardware store. Probably like Home Depot have it. So vertex, what else are the x? The axis of symmetry is just the x-coordinate of the vertex. So the axis of symmetry is going to be x equals 4. Again, that's just the x-coordinate of the vertex. Okay. And then x and y intercepts. Ooh, go away. So x and y intercepts. So I usually like to start with the y-intercept first, but I think this x with the x-intercept first. The x-intercept. So to find the x-intercept, what we do is we set y equal to 0. Okay. All right, so I'm going to use our standard form, right? So if we set y equal to 0, we're going to have negative 2 times x minus 4 squared plus 9 equals 0. All right. So if we subtract 9 on both sides, I'm going to go ahead and subtract 9 and divide by 2. We're going to have x minus 4 squared equals 9 over 2. Then we take the square root on both sides. To take the square root, we do plus or minus. This cancels this. So whenever we do square root, we have to introduce that plus or minus. Then we're going to have x minus 4. So we're going to need to rationalize. The square root of 9 is 3 over the square root of 2, but we typically don't leave square roots in the denominator. So we're going to multiply by 1. This is called rationalization or rationalizing. We're going to multiply by root 2 over root 2. All right? So then the result we get this x minus 4 plus or minus 3 root 2 over 2. And then we add 4 to both sides. 4 plus or minus 3 root 2 over 2. Something like that, right? Those are the x-intercepts. And then for the y-intercepts, I know this is a little intense. You just have to do the best you can. You got to team up with people. You got to push. Like, I know it's intimidating. You have to make a decision. It's really a decision. Are you going to let this stop you? Did you come this far to get stopped by this? Or are you going to find a way, right? And where there's a will, there's a way. But I know it's intimidating. You got to keep going until something clicks, right? So that means do what you can on your own. Try to team up with your classmates if possible. Definitely seek out the tutors and definitely make use of my services by like either the Ask My Instructor. Ask My Instructor is going to be the best thing. Or you can ask me during class a lot of times too. We have time. And then next was the y-intercept. So let me kind of just block it off like this. The y-intercept, again, what we do is we set x equal to 0, all right? So if we go back to the original, if we set x to 0, notice this term goes to 0, this term goes to 0, and the only thing that's left is the negative 23. So the y-intercept is going to be y equals negative 23. That's why I usually like to start with the y-intercept. Oftentimes, the y-intercept is much easier to find than the x-intercept. That happens very often, quite often. Okay, I think those were all the parts that were being asked. Okay, so let's display the whole thing at once. We can do like, kind of like that. I know it's a little bit, let me do like this with the paper. Okay, so you can at least see the whole thing if you wanted to screenshot. Also, all these things you see me writing, I'm gonna make all this available in our shared box folder. Let me check the chat. Let me first, before I check the chat, let me put this in Pearson. So we're gonna go like that and hop over to Pearson. Pearson is this way. Okay, write this in standard form. So from what we had, let me fix that view. That's better. So the standard form that we got -2 parentheses x minus 4 squared plus 9. Okay, that looks good. So from the standard form, it's a parabola where we go right 4 and up 9, and it opens downward. Right 4, up 9, opens downward. This does that. This is the only one that does those three things. Right 4, up 9, and opens downward is this one. I'm going to go with this one. The vertex occurs at 4, 9. Ordered pair, so we're going to say 4, 9. The axis of symmetry is going to be the x-coordinate of the vertex. Type in equation, so that's going to be x equals 4. Okay. X-intercepts. Okay. So the x-intercepts that we got, the first one was 4 minus, we got this 3/2 times the square root of 2. And then we got the same thing, copy. And I'm just going to copy and paste. And instead of minus, it becomes a plus. Okay. Okay. The y-intercept we got was -23. Integer fraction. The y-intercept, we got -23. I'm just going to type -23. Okay. All right. Let me check, see what's going on here. Nobody's in the waiting room. Let's see what's going on in the chat. I think we just did number 11, right? You got it? Okay. There's another one that my earlier class did that was pretty good about max and min. Let me see. Let me kind of jump around a little bit. Not that one. It could have been that one. I think we did this one already. Let's do this one. This is another one on max and min, right? So you can kind of test yourself to see do you truly have it or not. Okay, let's go. Let's do this. Let's go paper. Let's do some graph paper. Okay, that looks good. Do we need to write? More than likely we're going to need to write. So let me go ahead and prep my notes. So this is question number 15. This comes from section 2.1, question 47. It says a quadratic function is given. Determine whether it has a max or min and find it. So part A says to find, or let me see. I want to put max or min and put a question mark. I need you to go away. Max or min, question mark. If so, find it. Okay. And then part B asks us to find the range. Let's say range, question mark. Okay. And we're given that f of x equals, did we do this? Is this the same or different? 2x squared minus 20x plus 53. Now, I'm just sharing with you what comes to my mind when I do this stuff. When you're working on your own, you could definitely make use of this question help. If you click on question help and click on view an example, it's the same question with different numbers, which is pretty much how you'll see it. And then it'll give you an explanation. Like, first compare this, determine the values of A, B, and C, and it'll walk you through. If you hit continue all the way, it'll give you all the details for free. I mean, well, not for free. Sorry, it's not free, but it'll give you all the details. It's included in our setup, right? Let's see. But I'm just going off the cuff with what is aware in my mind, right? Does the quadratic function have a max or a min value? Okay. Well, here, we don't need to do anything here. So now, this is a parabola, and notice the leading coefficient is positive. So that means the parabola opens upward. That means we have a minimum value. All right, I think this is kind of a repeat. Okay. What is the minimum value? So the minimum value is going to occur at the vertex, so we need to find the vertex of this. So let's hop over here, and we need to show this. Okay. So now the vertex. Again, the x-coordinate of the vertex, which is going to be our h, is going to be negative b over 2a. Okay. So that's going to be negative, our b in this case is negative 20 over 2. Our a is 2. 20 divided by 4 is 5. So then the minimum value is going to be our y, which is going to be our k. That occurs when, if we just do f of h. So whatever answer we found, we just pass it through the function. So in this case, we're going to do f of 5. So that's going to be 2 times 5 squared minus 20 times 5 plus 53. Okay. 5 squared is 25, so that's going to be 50 minus 100 plus 53. 50 and 53 is 103, so then that's going to be 3. So we're going to say the minimum, what do we have? We said the minimum value, the min will occur, the minimum value of 3 occurs at x equals, I think we got 5. Okay. Style, like this, okay? When x is 5, what were the other questions? Let me hop back over here. So what's the minimum value? Let's go ahead and hop to Pearson. So let's see if we do like this. Pearson is this one. What is the minimum value? The minimum value is 3. Okay. The range. So the range is the very bottom to the very top. If the minimum value is 3, that means, and we actually do reach that. So the 3 is going to get a square bracket, and there's no maximum, so it's going to go off to infinity, positive infinity. Infinity always gets a parentheses. Okay. That was that one. There was another one that we did, but I can't think of which one it is. Let me see the chat. There's nothing in the chat, so I'm just going to go back to the before we got requests, wherever we left off. Unless we get another request. Okay. So let's go ahead and look at number 8. What's the time? We're going to go for about another 15 minutes. Determine the quadratic of this form whose graph is given on the right. Okay, so we have these 2 ordered pairs, and we just basically want to find the quadratic. Okay, we need to take some notes. So this is question number 8. All right, this comes from 2-1-23. We have the vertex occurs at -1, 0, passing through 0, 1. Okay. Okay. So let's hop over to the tablet and let's show the tablet. Okay. So first, let's go ahead and write the standard form of a quadratic. That's going to be f of x equals a times x minus 8 squared plus k. Okay. So then let's plug in what we have. Now this is our h, this is our k, this is our x, this is our y. So then our y is 1 equals A we don't know. X is 0 minus H is -1. Notice my use of parentheses, and our K is 0. Okay. So 0 plus 1 is 1. Squared is 1, so A equals 1. Ultimately, we get A equals 1. Okay. So that means our function, we're going to have f of x equals x. What's our h again? Our h is -1, so it's going to be x plus 1 squared, and that's it, because our k is 0. Okay. All right, and then we should check our points. So when x is -1, we get 0. When x is 0, we get 1. Okay, those check out. Let's hop back over to Pearson and submit our result. All right. So we got x plus 1 squared. X plus 1 squared. Awesome sauce. Okay. Let me check the chat really quickly. Looks good. Let's go to the next question. Quadratic function whose graph is given on the right. Okay, let's do this one. So this is what, number 9? Let's start about right there. So number 9. This comes from section 2.1, question 25. We're given that the vertex is going to be 3, -8. And then we're going to say passing through 2, -7, 2, -7, and 4, -7. Okay. Okay, let's show our notes. So we got to go like this and show it there. Okay. So if we're doing a standard form of a quadratic, we have f of x equals a times x minus h squared plus k. All right. So this is the vertex. This is our h and our k. I'm going to choose the point on the left because the number is smaller, right? So I'm going to say x and my y to plug in. Okay. So if we plug in these coordinates, we said the y is -7, a we don't know, x is 2, h is 3, and our k is, instead of plus, it's going to be -8. Okay? If we keep going, -7, a, it's going to be -1 squared is 1, so it's a minus 8. So then a equals, it looks like a equals 1. Okay? So then we're going to have f of x equals, it's going to be x minus h, so x minus 3 squared minus 8. Okay. So this should be the standard form of the quadratic that passes through those 3 points. We should verify that this works for all 3 points before we submit it. Okay. So when x is 3, y is indeed -8. That checks out. When x is 2, 2 minus 3 is what? -1 squared is 1, minus 8 is -7. That checks out. When x is 4, 4 minus 3 is 1, squared is 1, minus 8 is -7. So that checks out as well. Okay. So I'm going to submit this into Pearson. So let's hop over to Pearson. And Pearson is this way. We got x minus 3 squared minus 8. X minus 3 squared minus 8. Okay. We got about 10 minutes. Let me check the chat. No requests, so I'm going to go on to the next one. Have we done this one? Write it in standard form, find the vertex. Okay, let's write this one out. Ho, ho, ho. I am spent for the day. All right, what is this? Number 10. Numero 10. Number 10. Okay. Oh, I just realized this one of the students' name is Diaz. Is that right? Uno, dos, tres, cuatro, cinco, seis, siete, ocho, nueve. Diaz, right? I never realized that the name Diaz is number 10. It never registered to me until now. Okay. I think I'm saying that right anyway. This comes from section 2.1. Totally thinking out loud. Like this, right? Oh, you can't see this. We're taking some notes. Graph the given function, write it in standard form, then find the vertex. Okay, so we're asked to find the vertex, axis of symmetry, okay, x and y intercepts, x and y intercepts, okay, and we're given that y equals, we got this x squared minus 2x, okay, writing in standard form, so I'm going to say standard form, okay. Let me show my notes. Look it this way, and let's show it here. Okay. I'm gonna do another demo on completing the square. So again, the original was y equals. We got this x squared minus 2x. Now, fortunately, our leading coefficient is already a 1. Right? The leading coefficient is already a 1. So then we're gonna do again. We're gonna add 0 by doing plus b over 2 squared and minus b over 2 squared. Okay. Again, our b in this case is going to be negative 2 over 2 squared and minus negative 2 over 2 squared. Okay. So then if we crunch that number, that's going to be what? Plus or minus 1? Negative 1 squared is 1. So we're going to say plus 1 and minus 1. So we're adding 0 by adding that number and then subtracting it by. And everything else, we're just going to get a copy of it. It stays the same. Okay. So then from here, we can do factor by grouping. If we focus on the first 3 terms, if we group the first 3 terms, it should factor, right? That's the whole point of completing the square, is that now we can factor a portion of it. So we're going to say, I think it becomes x minus 1 squared, and then that final minus 1 comes down. Okay? So this is the standard form. This is one part that they asked us to do. Style, like this. Standard form. Then the vertex. I'm going to bypass the vertex formula and just trust this. So our vertex should be 1 comma negative 1. Okay. Then the axis of symmetry. Again, the axis of symmetry is just going to be the x coordinate of the vertex. So that's going to be x equals 1. Okay. Then ask for the x and y intercepts. Okay. So to find the x-intercept, what we do is we set y equal to 0. Okay. I'm going to trust my standard form. I feel like it's okay. I'm going to set that equal to 0. So we're going to have this x minus 1 squared minus 1 equals 0. Add 1 to both sides. Then we get x minus 1 squared equals 1. Take the square root. So again, if we take the square root on both sides, remember, whenever we do square root, we have to introduce plus or minus. Okay. On the left, we have x minus 1. Square root of 1 is 1. So on the right, we get plus or minus 1. So then add 1 to both sides. X equals 1 plus or minus 1. So then x equals 1 minus 1 is 0. 1 plus 1 is 2. So these are the x-intercepts. This is the way that Pearson has been accepting our intercepts. Okay? So then that's for the x-intercept. For the y-intercept, what we do is we set x to 0. Set x equal to 0 and solve. Y-intercept often is a lot easier. If we go back to the original, right there, if we set x equal to 0, then y is 0. Right? So here we get y equals 0. Okay? So that means the origin is the x is one of the x and y intercepts. Okay. And I think those are all the questions there. So I'm going to just display them all kind of like this. And let's go like this. The paper, let's do like this. Okay, let's hop over to Pearson and check it there. Standard form. Okay. So standard form, we got this x minus 1 squared minus 1. Okay. Equation, right? So we need to say y equals. We need to say y equals. Okay, that looks better. So the transformations, we're going to go right 1 and down 1. So shift the graph of this 1 unit to the right. And what did we say? 1 unit down. Okay. Then we're asked the graph. So we're doing a parabola. It just says click to plot. Okay, let's plot the vertex. So the vertex was 1, -1. So here, 1, -1 is there. Oh, let me see. Oh, okay. No, edit. Let me just clear. Okay, so let's just click to plot. So now we just take the parabola. We said we go to the right. So horizontal shift to the right by 1, and we go down by 1. I think that was it. Right 1, down 1. Save and check. Okay. Then the vertex. The vertex was 1, -1. Parentheses 1, -1. Okay. Axis of symmetry is going to be the x-coordinate of the vertex, so this is going to be x equals 1. Okay. X-intercepts, we found them to be 0 and 2. We said 0, 2. And the y-intercept we said was 0, just the origin. Okay, I think that's the last part. All right, so that's enough for one day. I'm going to go ahead and load a copy of the notes that you saw me taking, so let me go ahead and do that now. Ooh, good shot. If there aren't any burning questions, I'll see you guys tomorrow at 5 o'clock. Okay? Otherwise, I'm here if you wanted to ask a question or two. All right, guys, enjoy the rest of your day. Take care.